In the previous videos, we mentioned about producing a structural key plan on basis of the architectural drawing. You know that the structural key plan provide information regarding the layout of the beam, which this layout of the beam will affect the distributions of the loads from the slabs to the beam and then to the column and finally to the foundations. There are various factors to be considered dealing with the beams, and there are various ways to deal with those considerations, which different designer will lead to different structural key plans. In fact, there is no right or wrong in terms of the structural key plan proposed by the engineers. It is the matters that how the loads are being distributed from the building elements to the structural elements. The bottom lines are you need to ensure the integrity of the structures, where every single element must be stable, and you should not compromise the design of the architect. You are allowed to provide structural element within the building without affecting the aesthetic view as decided by the architect. You're going to hide the structural element within the ceilings, within the walls, and underneath the floor slabs. And your design should provide sufficient flexibility for the installations of the architectural fixtures. There are some concrete elements which are rather heavy and needs to be attached to your structural element. You need to make sure those are taken into considerations. You will need to imagine the structures in 3D. For every single part of it, be mindful about the minor details, where these are the common places that students overlooks, which can lead to the problem to the contractor in realizing the actual structures in the realities. There will be integrations in terms of the knowledge for the structural design as well as the practical constructions. In the previous videos, we mentioned about the considerations related to the beam. We will proceed with our discussions in terms of the considerations related to the column. When you produce the structural key plan, you will need to also indicate the positions of the column, the alignment of the columns, and probably propose a size of the column. This is at least to kickstart the analysis and design. If the proposed size fails, you will need to enlarge the column, and if the proposed size is passed, probably you want to do one more trial for the smaller size column to check if you have oversized the columns. Sometimes there are some aesthetic column which is also a part of the architectural design that the architect has already indicated the shape and size. In this case, you will need to follow the size given by the architect. Normally, architect has some knowledge about applications of the columns. They will propose some locations for the column, which normally there are reasons for them to put the column there. Most likely, those columns are required in the subsequent floor levels. I would say that most of the column proposed by the architect ended up to be quite necessary. As for your first draft of your key plan, probably you use the proposed locations given by the architect. Sometimes you may need to add more columns in order to shorten the effective spans of the beam, which in this case, the additional column cannot be seen from the aesthetic view. Those columns will need to be hid within the walls, and make sure those columns doesn't clash into the doors and windows. You cannot add any column at the open space. There are usually good reasons to have space in the building. You know that the open space in the building will be the utmost concern by the client. They would like their rooms to be as big as possible without any obstructions. For example, you cannot simply put any column at the middle of the living rooms. This will be rather unpleasant to the client. It will be up to your creativity through numerous trial and errors to find the best locations of the hidden columns, so that the forces are effectively distributed from the buildings to the structural element, and so that your structural elements can be effectively hid within the architecture fixtures. You also want to design the structures to be as economical as possible. That means you might need to have good combinations of the beam, slab and columns, mind the effective spans, which can lead to significant increase of the amount of reinforcement bar embedded in the structural elements. You can embed the columns in the walls. Make sure that it doesn't stand out from the wall surface. Let's say now you are talking about a single layer wall, which the width of the brick wall is 115, plus the plastering at the both sides of the wall. The width of the column to be embedded within the wall, it will be more or less 150 mm. You know that there are concerns also when the width of the column to be smaller than that. This will be related to the workability of the columns, especially when you need to construct the columns. Pouring the concrete into the formworks, due to the limited space within the columns, you will have problem with the compactions of the concrete. Therefore, I would say that the smallest width for the column, it will be 150 mm, for it to just nicely embedded in the walls without affecting the aesthetic view of the building. Sometimes you will need column at the joints of walls, especially when the wall is at the right angle. Putting a column or a stiffener, it will be helpful to ensure the proper alignments of the walls. Next, you need to be careful with the offset column. The meaning of offset column is demonstrated in the diagram here. You have a grid line here, and the beams and columns are put at the edge adjacent to the grid line. However, suddenly there is a span here with the offset column, which is some distance from the grid line and some distance from the grid line. And this normally happens when you have continuous windows crossing two levels of buildings. Let's say now you are dealing with the first floor beam here, and you have continuous window from the ground floor stretching into the first floor. And in this case, you will need to allocate space here, which is equivalent to the minimum width of the brick wall, somewhere about 115 to 125 mm, which is just nicely for the width of the window frame. That means the architect purposely offset the column here so that the window can fit in, and so that the view of the structures are properly aligned throughout the walls. In this case, you need to be extra careful with this kind of offset column. Normally we like continuous beam member, but due to this offset column, we cannot allow the beams to be continuous here, as the beam will also clash into the windows, which in this case, the beam will also be offset, giving way to the windows. When this happens, you will need to be careful with the size of the column here, that whichever beam connected to the column, you will like the entire beam to be attached to the column, because the joint between the beam and the columns is utterly important. You have reinforcement bar to be embedded in the column. If you offset the beam here without increasing the size of the column here, Later you will have problem for the beam, especially its reinforcement bar to be embedded in the column. Then the continuity between the columns and beam, the monolithic response between the column and beams will be questionable. You have to be careful about this. Next, the locations of the column is sometimes governed by the maximum allowable span for the beam, which normally within the 9 meters. The further the columns is apart, the longer span the beam it is. This will significantly increase the size of the effective depth. If you have no restriction in terms of the maximum effective depth of the beam, that should be no problem. But for typical residential, commercial and office purposes, most likely you cannot hide your beam within the ceiling, especially when you have a span more than 9 meters. And when you try your best to limit the effective depth of the beam now will be not in the most economical aspect ratios of the width versus the height. You will encounter a wide beam with short effective depth. This is very uneconomical design, and you will need a lot of reinforcement bar to strengthen the beam in resisting the bending moment. Wide beam in the structures will be the last choice of engineers, not only on the economical aspects. On the practical aspects is also a concern. You have so many reinforcement bar that you have sufficient space within the wide beam, but when it comes to the joint between the beam and columns, and there are another beam incoming from the perpendicular directions, you will have problem with the congestions of the reinforcement bar at the joint, which is quite difficult to handle on site. It is only that you cannot find any locations for you to put additional columns, especially when you're not allowed to put any column in the middle of the open space. Then you have no choice to use the wide beam so that it is hide inside the ceilings. Then you need to be extra careful with the congestions of the reinforcement bar at the joints. In fact, it is always good of you to communicate with the architect, see if any amendment or any proper solutions can be come out. You may also propose locations with the minimum impacts to the aesthetic view and seek the consent from the architect. If the architect is okay with it, you may proceed. In the case that you seek consent from the architect, make sure you tackle their concern regarding the aesthetic part. You cannot simply put any column at any place, which obviously going to be a concern to the client. Most likely your proposal will be turned down. You will need to find a balance between your needs as well as the needs of the architect. This is the only way that you can come to a common ground in resolving the issues. Next, you need to consider the hatch and non-hatch issues regarding the column. This needs to be presented in the structural key plan. Sometimes you see the columns being hatched, and sometimes you see the columns are not being hatched. There is a meaning for that. You can't simply put hatching of the column, or you decided not to hatch the column and expect the contractors to understand how you intend the columns to be. You know that the column, when it is hatched in the key plan, something like this, that means the column will penetrate through the floor plan and going up of the floor plan. Your structural key plan is on the plan. Let's say now you are doing the structural key plan here. When you hatch the column, that means there will be columns going out of the floor plan. And when the column is not hatched, that means the column will stop at the floor plan. This need to be careful. It is also a common mistake by the students. And then next, you need to be mindful about the column schedules. Normally on the practical considerations, you need to limit the numbers of types of columns in the structures. You know that based on your calculations, every single members have their own reinforcement, but you have so many columns in the structures. For a typical terrace house or typical commercial buildings which are attached together in several units, the numbers of columns can easily reach to 100 units. Imagine you have 100 column design in the key plan. This is going to be quite confusing, quite tedious to refer, and every single columns with different design will be quite difficult to manage in the construction site. Normally we will reduce the type of the column within the structures. Let's say now you have the column schedules. Certain columns are being grouped together. Make sure all the columns within the group will not fail, and there will be about 10 groupings of the columns to cover a total of 100 units of column in the building structures. Then this will be quite easy for the contractor to monitor as well as to construct in the construction site. You know that the construction in the construction site is not only adopting the reinforcement bar. There will be extensive reference with the technical drawing, and then before the casting, normally they will go around and then check the reinforcement bar again. It is because you cannot do any amendment after the casting. Therefore, everything needs to be checked properly before the casting takes place. It is not only for the contractor. There will be site engineers also supervising the project. They will also be checking of the reinforcement bar in the columns. Grouping of the columns, it will be helpful for them to make a quick check and increase the productivity of the works. Now let us look into some examples of what we have mentioned just now regarding the considerations of the columns. This is an example of the architectural plan. There are many informations and details given in the architectural plan. What you see here, this architectural plan is actually quite neatly produced. They have indicated the proposed locations of the columns, which are in proper arrangement in the grid line. They are properly aligned in the horizontal conditions and properly in line in the vertical conditions. That means this architect seems to be quite experienced, which in terms of the design, the architect has already taken into considerations of the needs of the engineers. There are proposed columns. Some is allowed to hide within the wall. Some is going to be exposed columns. For those hiding within the wall, you need to make sure it is properly hid within the width of the wall. This brick wall is double layer brick wall. Then you can have a wider columns. There are also the wall which is single layer. The column size will be relatively small. There will be exposed column, and you will need to follow the size of the exposed column. In the case that you would like to change the shapes or increase the size of the column, you will need to seek consent from the architect. Let's say now you have beam crossing the columns here, and then you find that the effective spans between the columns seems to be rather large, and you would like to shorten the spans of the beam. You cannot simply put a column somewhere in the open space. This is definitely going to be rejected by the architect. It is especially when the architect is very familiar with the practices of the engineer, which based on their experience, they know the maximum allowable spacings. You will have to come up with your own solutions to overcome this. It is either for you to reduce the size of the slab so that less stress is distributed to the beam, or you will need to enlarge the size of the beam and make sure it is high under the ceiling. If you see this part also, the architect also proposed the column. Most likely this is going to be another part of the aesthetic view. You can try to adopt this size. For a typical multi-story building, less than 3-story height, I believe the size proposed here is already more than enough. It is not necessary for you to increase the size of the column, since it's already indicated by the architect. Maybe you just adopt the size of the column. This is the offset column that I mentioned. Sometimes due to certain considerations, there are offset columns, which in this case, you will need to consider how you're going to have the beam to be laid to connect those columns. Different engineers may have different solutions for this. The bottom line, it will be the structural stability. We also mentioned about the hatch column versus non-hatch column. This can be seen here. This column is hatch. That means it's going to penetrate through the floor plan and going up of the floor plan. And this is a non-hatch column. That means the column will stop at the floor plan. Sometimes you also encounter the column where the columns below the floor plan is bigger, and those which actually penetrate through the floor plan, it will be smaller. As indicated by the column here, the non-hatch regions is bigger and the hatch regions is smaller. That means the smaller size of column will penetrate through the floor plan. Similar goes to this column as well as this column, which in this case, the column that actually penetrate through the floor plan, it will be this part, which below the column, this will be the size of the column. One thing that you need to keep in mind, you can reduce the size of the columns as the columns goes up. Normally, we will not go for increasing the size of the column when the columns go up to the following stories. This will have problem with the integrity, and it is also not logical. You know that the columns at the bottom normally endure higher axial loads as compared to the column at the top. You need to take this into the considerations. We also mentioned about the grouping of the columns. Let's say now you see the key plan here. There are so many columns here. Through your calculations, in fact, you can have different design for each column, but this is not practical. You can always group the columns so that you have this many columns to be grouped into several groups as compared to the total column available in the structures. Probably let us take some time to look into the column schedule. You have this as a parquet level. This is below the ground floor, above ground floor, above first floor, and second floor. What you see here, the column schedule gives you the informations. There will be some column stopping at the first floor, and there will be some column stopping at the ground floor. Informations needs to be in line with the structural key plan. When it stops here, that means in the column schedule, it should also stop. When the lower column is bigger size than the upper column, this will need to be reflected in the column schedule as well.